Okay. Oh, I almost forgot. I'm going to remember. The second chance LO1 quiz and interview grades are posted. I believe for the quiz, they're posted in the original quiz thing, but for the interview, they're in a separate assignment. So take a look at those. We're going to standardize that. We're going to do a second assignment for all of them moving forward. We've been discussing like how to represent that. If you didn't need that, if you have a one for either of them, you have a one for that thing, that either LO1 LO1 read or LO1 explain. If you have credit for either the first chance or second chance for that category, then you have credit for it. Yes?
Is this week's quiz is the result for this week's quiz going to be released next week or?
Good question. Will the results for this week's quiz be released? When will they be released? We're aiming for still Wednesday. I was just talking to some TAs about this, whether they want to grade over break or not. And the overall answer I got was that they don't mind grading over break. So I think we will get those results, but if not, when we get back from break soon thereafter, they should be released. But I'm hoping we get them released by next Wednesday.
Thank you.
Any insight on that, Nicholas? Do you know how interview grading is going? Okay. And quiz team is getting started with that, so should get those going. But the second chance, so if you took the first chance and second chance, either interview or quiz for LO1 and did not get credit for either of them, there's no action that you need to take yet. I'll be processing everything tomorrow. I'll probably send an email or a TA will send an email about scheduling things. The TAs will handle the reschedules, give you interviews and quizzes that will be outside of your regular lab section. The recovery opportunity using that is going to be automatic. You don't have to email me and say I want to use a recovery opportunity. It's just implied that you're going to use it if needed. With that, any other questions before we get started on this lecture? Is my Discord broken? Has there really been nothing in here since 3:12 this morning? In both the other 116 lectures?
Something new. Now we have.
Okay, yeah. Something. All right, thank you, Artemis. Confirmation that this is working. I do have internet and Discord's working. I heard it wasn't working, I think early this morning. Anything else? Yeah, the task 2 deadline as well. I'll be, is that where we are? Task 2, it always throws me off. Why do we have a project 2 task 2 deadline? Like I'm already into LO3 now. Why is the deadline so late for that? Maybe that's something we have to address. But anyway, the task 2 deadline, if you need an extension on that, again, if it's your first extension, you don't know how this goes yet. I do have to manually add the extensions in Autolab, so it does take a little while to process things. I'm hoping to do that tonight, but if I do crash tonight, I did last week and got them done in the morning. But if I do crash tonight, tomorrow morning, I'll be processing those, getting all your deadlines in, because right now you can't submit to Autolab. I do have good news for you, though. If you do need another recovery opportunity for a deadline extension, in my mind, I don't consider spring break a week in the schedule. So if you do need a recovery opportunity for anything that you missed this week, either task 2 or if you used a recovery opportunity on task 1 or a previous thing and need to use another one, it is a 2-week extension for free. I assume that you're not going to work over break. It's probably a false assumption, but just when I'm making the schedule, I don't consider spring break a week in the schedule. Get your rest. That's your time to rest, relax, recover, recuperate. Don't kill yourself over break and come back exhausted again. You won't be able to make it through the rest of the semester. So it will be a 2-week extension if you need to use a recovery opportunity for a deadline you missed this morning. Likewise, if you do work over break, you do have 2 weeks to work on, to catch up on this stuff as well.
No variables.
Rand, you're not even here. Yeah, I'll send you an email. So when I do process things and you get an extension, I think I got sidetracked and lost my sentence there. But if you need a recovery opportunity for a deadline extension, I'll send an email also saying, hey, you got your extension. Here's your new due date. I open up Autolab, and you can submit again, and letting you know where you stand with recovery opportunities. For the interview and quiz as well, either myself or a TA, I think I'll send an email that'll say a TA is going to follow up with scheduling details for those ones, just because I want to be the one sending the emails about recovery opportunities.
They do ask for your offering.
Should we occasionally update our 116 examples code with the one from GitHub in case there's anything added? Yes. I don't think I added anything in the past lecture, but last week I updated something with the repo. The whole TV example is completely rearranged from last semester. So Thursday night, I think I updated the thing. Yeah, you should constantly be polling. And you don't have to re-clone the repo. You just click that blue arrow in the upper left-ish corner of IntelliJ, and it'll update the code for you. One press of a button and you update the code. Don't do anything more complicated than that. And if you don't remember how to do that, check out the week 2 or 3, I forget. The first lab, the IntelliJ setup lab document, it goes through polling from the repo. And it'll show you what that button looks like. But it's just one click of a button. Unless you change the repo, things get a little more complicated. I'll be happy to help you through that. Are memory diagram quizzes at most as hard as the game object lecture? Yeah, you won't see something as hard as the game object lecture, in my opinion. I always have to say in my opinion with that one because somebody might disagree. But the game object lecture where we have double inheritance, where health potion, extended game object, extended physics object, with just one of those, we can test you on what we want to test you on. We don't have to have 3 constructor calls going on the stack. So it'll be a little trimmed down so it can easily fit in the lab time. If you can do that game object example, for the most part, you should be good. There might be something that wasn't on that example, though. Polling code from the repo won't override what you've written, but it will ask you to merge what you've written. So it'll give you a bunch of interfaces to be able to merge your code with the code from the repo that changed. It's painful if you've never done it before. It can be painful. Okay, let's get through these. So today, aside from this last sorting example, besides merge sort that we'll see after break, besides this, today's lecture is just going to be a variety of collections methods that you can call on data structures. We've called a few of them so far: sorted and sorted. I guess sorted, sort by, and sort with. But I thought we did one thing that's not sorting, but I'm not thinking of it. But more methods like that you can call on data structures to be able to get stuff done really quick and without conditionals. Without vars, without variables. So that's most of what today is going to be. But first, we need to talk about one more sorting example, which I'll use as a way to talk about returning functions. In task 1, the last method that you have to write is a method that returns a function. It's going to return the song cost function that you'll have to write. So you write a function and then return it from the method. So how would we do that? So let's talk about this example, this question. What if we wanted a comparator that takes 3 parameters? A comparator has to take 2 inputs. The comparator just says, these 2 elements, which one comes first? That's what we use a comparator for. But what if we want a comparator that uses a 3rd input? How do we do that? Well, the answer is we kind of can't. We can't just take a 3rd input in the comparator because that's not how the sorting methods are written. The sorting algorithms take a comparator that takes 2 values and returns a Boolean. You can't give it 3. So what if we wanted something where we want to sort points, like 2-dimensional points, based on their distance to a 3rd point? So I have some reference point. So the example is I have a game that I'm playing. The game examples, I think, tone down after the few examples, if any of you are getting tired of that. I have a game map, a two-dimensional grid. I have the player at a specific location at a specific point in time that's always constantly moving around. And I want to sort all the objects in this world by their distance to the player. So that would be our application. I want to get a comparator that's going to compare two objects based on their distance to a reference point. How do I do that? I would like a comparator that's going to take 3 locations and then write some code that's going to take that third location into account. But I can't do that because that's not what comparators do. For the homework, we have the same situation. We want a cost function that's going to take a specific user's ratings into account and have a cost function that rates songs for a particular user, but the cost function only takes a song and returns a double. And when you get to the application objective, that cost function is going to be used in the genetic algorithm to take in one song and return a score. How do we take the user's ratings into account when we can't add another parameter? That's not how the function works. That's not how comparators work. It's not how cost functions work. And the answer is build a function dynamically with the extra parameters built into it. So if I want to write a distance comparator that's going to take 2 vectors, 2 locations, and return a Boolean, but I want to sort based on distance to this reference point, I'm going to write a method that returns a function. I'm going to write my function, return my function, which is my comparator. That function's only going to take 2 parameters, the 2 that are required, but it's going to have a third parameter, I like to say, baked in to the function. So the method takes in the third point, uses that third point in the definition of the function, and then returns the function that only takes 2 points. So I'm taking the information of all 3 points into account by putting one of those points into the function itself, writing a function dynamically based on whatever this is. This can be changing throughout my code. I can get 100 functions with different reference points for different comparators. I'm going to bake that into the function and return a function that takes that reference point into account. So I would call distance comparator of the location of the player. Give me a comparator that sorts based on location of the player, and then throw that comparator into my sorting method. Same thing with the homework. We're going to write something that takes a method that takes the user ratings into account, and then return a function with those user ratings baked into the function, and return a cost function that's specific for that user. And this is how we can get a lot more flexibility in our comparators. Even though we're confined to this takes 2 physics vectors, returns a Boolean in our comparators, we can still take advantage of that by adding extra parameters into the function and building functions dynamically. It gives us lots of flexibility when we don't have to have every function defined before we run our code. Like we do with methods, we have to define our methods before we write our code, before we run our code. Here we can say, well, here's the function, but it's going to need more information before you actually create it, and then create the functions dynamically. Very powerful concept. Very powerful idea. You're only asked to do it once in this semester, just writing that song cost function, but it's a very important concept that we can use a lot, that you could use a lot. And when you want to use this, so say you want to sort points by their distance from 0.5 on a 2D grid, you call distance comparator, give it the reference point. This returns a function, your comparator function, and then you can call merge sort, which we haven't seen yet. We'll see that on Monday. Same idea of selection sort. Takes a list of a type and a comparator of a type and compares them. So take your points, not shown on screen, sort them using this comparator, which is going to sort them based on their distance to 0.5. No stopping you. You can sort in any way, anything in any way you could ever imagine with these tools if you generate comparators dynamically. With type parameters and generic sorting methods that take type parameters and comparators, we can sort any way you want. You can sort way more ways than you ever cared to sort. All right, any questions on this one? This is the last thing I want to talk about, like first order functions. So we can write methods that take a function as a parameter. We have our selection sort that took a comparator. We have a method that returns a function. We stored functions and variables. Any other questions on functions before we go into collection methods, which I want to talk about the rest of the lecture? Wow, I read that way wrong. Sounds like everyone's okay with this. Moving on then. So there are a lot of methods that we can call on collections. I'm going to call most of these on the list class. List has a whole bunch of methods as part of it that take advantage of first order functions to get different things done. And I'm just going to go through them, a whole bunch of them. We're going to see a whole mess of these, one after another, kind of rapid fire. It's going to feel kind of like one of the first lectures in this semester where here's this thing, here's this thing. But they all follow the same theme. So I want you to get familiar with these. I don't expect you to memorize all these, by the way. I expect you to understand how they work, like the idea behind the overall concept of how these types of things work. And then if you need a specific one while you're writing your homework, you should be able to look at the documentation or rewatch the lecture or something to figure out exactly how that specific one works. So let's just talk about what these are. Let's start with the simplest one, for each. So if you want to call a function on every element of a data structure, we can do that by saying data structure dot for each, and then a function, I'm giving it the println method in this case. And then this function will be called on every element of that data structure. So I'm saying println 0, println 1, println 2, println 3, and I'll get this output from this program. I'll use this in the rest of the examples just as the last line so we can see things printed to the screen. I can show you what's printed to the screen. This is the same thing that happens if you create a for loop. We actually don't have a for loop in Scala. It's kind of an illusion. It's actually a for each loop, which iterates over a data structure. There's no true for loop. It's always a for each loop. And the loops actually call a for each. It takes the code in your braces of the for loop, turns that into a function, and then calls for each on it. So this is the same thing as basically flattening down a loop into one line of code, which can be convenient. Well, actually, for each is not very convenient at all. But the idea can be convenient when you want to do something like the accumulator pattern, but you don't have a variable. How do you do that without a variable? Well, that's my way of forcing you to use these types of things, these ideas, functional programming ideas. So this one gives you a loop without a variable and no loop. But you can only call these functions for their side effects. I'm calling println for its side effect of printing to the screen. If I actually want a function that does something, for each really ain't it. But it's the simplest one to show as a first example. So let's get something more interesting. Oh, I want it to. So let's get something more interesting and call .filter on a list. If I call .filter on a list and give it a function that takes one element, one parameter of the type of the list and returns a Boolean, that'll return a list of all the elements and only the elements for which that function returns true. So I'm going to say the word.length greater than 3 for 0, true, false, false, true. So only the elements that are true are going to be in the output of that. So if you want to remove elements from a data structure, slap a .filter on there, give it a function that takes one parameter of the type you're filtering and returns Boolean, and you'll get everything that returns false from that function is going to be filtered out of that data structure. I kind of wanted to update all these slides. I think it'll be fine, but I'm going to use this shorthand in lecture. Hopefully it's not too much. I think I can get away with the shorthand still. But I'm going to use this underscore shorthand. If you don't want to write the parameter lists, which it clutters up the slides, common theme throughout the semester, If you don't want to write the parameter list, this is a full function definition, which is the same as this. But instead of writing all that, if we're only using the parameter one time, exactly one time, we can replace all of this with just an underscore for the parameter. The underscore is in place of the parameter, and we have an anonymous parameter. We're not giving it a name or anything. I'm just saying whatever the parameter is, this is where it's used. So the input.length greater than 3. Just shorthand that Scala lets us do. You can't use this shorthand if you're not using the parameter exactly one time. And you can't use this shorthand if Scala cannot infer the type of the parameter. In this case, words is a list of strings. So this function has to take a string. So if you put underscore, Scala understands that that's going to be a string. So we're able to take advantage of this shorthand. I'll take advantage of it during this lecture. If you don't like the shorthand, feel free to continue using the fully written out way to define a function. Yeah, it's shorthand for the parameters. Only if you're using the parameter exactly once. If you need to use a parameter more than once, or you want to ignore a parameter, you have to write out the long way of writing it. For its worth. It's just one handy thing Scala gives us to be able to cut down our typing quite a bit. All right, so filter takes a function that takes one input of the correct type, returns a Boolean, returns a list of only the elements for which that Boolean was true, for which that function returned true. All right, we're getting kind of the idea of how these work. We're calling a method, which is going to take a function and then do something based on that function, calling that function on every data structure. That's the general idea of how these are going to work. And it's just rapid fire examples for the rest of the time. This one, map, in my opinion, the best one. I like this one. This is the most useful one. I use this more often than any of the other ones that I'll show you today. I would show it first, except I want you to warm up with the other two. This one is the most important, will be the most important on your homework right from the first method of LT1, hint. You'll want to use this thing. This map takes a function and returns a new list or a new data structure of the outputs of this function. So I'm giving this the square function. I'm saying numbers.map. So all these numbers, map them. So create me a new data structure with the outputs of this function after using all these inputs, these elements as inputs. So I'm saying, give me a new list with all of these numbers squared, is what I'm saying with this line of code. Give me a new list with just this, really. Give me a new list with all of these numbers, but square them all. You can send any function to this that takes an input that's the correct type for the list. So as long as I give it a method that takes a double, I can call map and get a new list with all of the same elements, but with that function applied to them, which is the way I always explain it. I think it's a little confusing the way I explain it, but I don't have a better way. But calling that function and all the elements of the data structure, collecting all the outputs of the function, and putting them in a new list and returning that list. In the homework doc, if you see with that function applied, that's what I mean. We'll print those to the screen, and we do, in fact, get all these numbers squared. All these examples, as usual, are in the repo as well, if you want to play around with them. So map, this is tremendously powerful, tremendously useful as well. Even when I can use variables, and I recommend this for you too, even when you can use variables, very handy. If instead of the alternative is create an empty list that's going to be your accumulator, iterate through this with a loop, call the function, append the output of the function to your accumulator list, and then return the accumulator list. That's what you got to do to set it up to be able to do this the standard way, like the 115 way, or .map function, done. One line of code, done. As opposed to 5 at least to set up the accumulator pattern. And I didn't put any condition on the output type. of that function. As long as it takes as input the type of the list, you can return as output any type you want and collect the results in a list of that output type. So if I have a list of strings and I want to convert this to a list of ints that stores the length of each string, nothing stopping me from doing that. Call .length on each input. I got my list of ints, and I got the length of all the strings. Pretty handy if you have a list of type T and you don't even know what T is, but you need a list of doubles, and maybe you have a function handy that converts T's to doubles, just .map. Yeah, and map isn't the data structure. Map, the method that we're using here, isn't related to map the data structure, but they're both related to mapping the concept. A map data structure maps keys to values. The map method maps these values to these values. So it is still a mapping, like in the mathematical sense. We're mapping one thing to another thing. So the concept is the same, but has nothing to do with the map data structure. Maybe you like map, the method, but you don't really like the syntax, or for whatever reason, there are multiple reasons, and one of them will come up in application objective, the application objective for this homework. Maybe for whatever reason, you want to set up a loop structure, but you want to effectively do the same thing as mapping. For that, we have the yield keyword. You put the yield keyword in between the setup for your loop, well, I forgot what this is called. Whatever's in the parentheses for your loop, I forget what it's called, and the body of your loop. In between those two, slap the keyword yield in there. And now you can assign the output of the for loop to a data structure. And the values of that data structure are going to be collected from the loop by effectively treating the body of the loop as a method and taking whatever the last expression that's evaluated as the values that you're collecting. So here, my last expression is always this math.pow. So as this loop runs, each time we iterate over the loop, we're going to collect this value into the output data structure. So very similar to map, but a little bit different syntax. If you're used to the for loop syntax and you want to stick with that, slap the word yield in there and create a new data structure. So if you need a loop where you're collecting information and you can't use var empty list, var list equals empty list, and then in your loop append to the empty list or prepend to that list and accumulate all your values because you can't reassign to the list without var. Yield, that's your friend. Yield or map, they'll do the same thing for you, just different flavors. Different syntax, different ways of setting things up. Yield is going to do its best to match the type of data structure that you're iterating over. So in the previous example, we were iterating over a list. Yield is going to return a list. It's not always going to give us the type of data structure that we want. So if you're doing something like this, which when you get to the application objective will be a handy thing you'll want to do. For 1 to 5, well, 1 to 5 returns a range, and Scala is going to try to collect these into a range, which it can't do ranges for numbers. It's not going to be able to, actually these are numbers, but they're doubles. Scala is not going to be able to get them in a range. I believe this returns a sequence. It returns some data structure that we don't care about in this class. So if you're ever iterating over something where you don't want that type of data structure and you would rather just work with lists, put parentheses around this whole damn thing. So whatever data structure type that returns, we don't care what it returns. Just slap a to list on it. And now whatever data structure that was, now it's a list. Then you can continue to work in lists, and we get comfortable working with lists. So let's just use everything as a list. So we can still work in lists, even though we're iterating over 1 to 5 and collecting those values. Let's work with the list. All right, how are we feeling? Yeah, the next one's reduce. How are we feeling so far? Is this feeling comfortable? Calling methods that take functions to get all kinds of stuff. And as we start using these things, you'll see that our code's going to get a lot more expressive. In very little amount of code, we'll be able to express a lot of meaning. And usually I think these are easier to read. For example, with the yield is about the same as before. But words, I want to map words using this function and create a new data structure. I think is easier to read, maybe not at first, but easier to read than the accumulator pattern, trying to accumulate into a list and do the same thing in 5 lines of code. Gets a little, a little harder to read, unless you're comfortable reading those, I guess. But we're expressing a lot more. In this one word, 3 little characters here, we're expressing a lot of meaning that we used to be able to need 5 lines of code to do. Yeah.
So is there a scenario where yields is going to be better than the dot map?
Where yield is going to be better than map? I was trying to think of one when I was talking about yield. I don't think so. Not off the top of my head, at least. But I feel like I did run into a situation before where map just wasn't doing it for me, and I pulled out yield, and it worked fine. But I don't remember the exacts of that scenario. I think yield is easier to write. I think sometimes map will just get pretty cumbersome if you have a really complex thing that you might just want the for syntax. I think that was my situation where it was just complex to jam it into a map. So I wrote my big loop, which had multiple lines and stuff, and just used this syntax because it was cleaner. I think that was my application. But there might be a different reason, too. I just don't recall off the top of my head. Any other questions? Are we feeling good about this? I don't want to just run away from y'all. Yeah.
Not exactly about this though, but passing methods as arguments to other methods, is that like specific to functional programming or Scala? Like, is that something that's in like all?
It's not necessarily in all languages. So the question is, passing a method to another method, is that a common thing? Is that something that we can just do? In Scala, we can do that. If a method takes a function as a parameter, we can give it a method instead. Not all languages will let you do that. It has to be part of that language to be able to do that. Yeah?
Does Python let you do that?
I was going to say, but I wasn't 100% sure. I think Python does. It does with methods. Okay. Python, JavaScript for sure does. JavaScript doesn't really even have methods. Everything's an illusion with JavaScript. I believe Java does not, unless it's a more recent feature. C++, I believe, does, but you have to use function pointers, which is a whole can of worms. It's really complex the way they do it. C will let you do it with function pointers. C doesn't have methods, so I guess that doesn't really count. But C, you can pass functions with function pointers as well. But it all depends on the language that you're using. All right. If there are no other questions, I'm diving into reduce, which is one of the last ones. But reduce takes a while to talk about. Reduce and fold. All right, if we're ready for it. So reduce and fold that we'll see in a second. This is truly the accumulator pattern in one line. So reduce is going to take a function, and I expanded it out this time so we can see everything because I wanted to name my variables. The reduce method is going to take a function that takes 2 parameters, an accumulator variable, and a single variable which has to match the type that you're iterating over. And for this example, the accumulator has to match the type as well. We'll not do that later. But this function is going to take 2 of them and then return the new value of the accumulator. So if I want to, in this example, sum up the squares of the values of the list, I want the sum of all the squares of these values. I'm going to take my accumulator and my element that I'm currently looking at from the list and add to my accumulator that element squared. I'm going to give that to the reduce method, and it's going to go through all of my elements one at a time and call this function on each of those elements. The initial element is going to be, or the initial accumulator is going to be the first element of the list. And then we're going to call this function on the first element as the accumulator and the second element as b. So we're going to get 1 plus 2 squared returns 5. And then we're going to call this function again with 5 as the accumulator and then 3 as the next element. Add 5 and 9. And then call the function again. Accumulator is 14 plus, and then 4 is b. So 14 plus 16, which, right, 30? I could do this. And then 30, and then 5, the next element. So 30 plus 25 is going to return 55. We're at the end of the list, so that's finally what's returned. Then we get 55 printed to the screen. So we can do a lot in just one pretty compact method call. We can use the shorthand here, which I will do on the next slide. We can still use the shorthand here and crunch that whole friggin' thing down to this. I don't always recommend compacting your code so much, but that option is there if you want to. Yeah.
So that is the exact same in terms of functionality as what was on the previous slide.
Yes. This is the same thing as the previous slide. Let me explain this a little more. So we're using the shorthand here, but we have 2 parameters now. This only works if you're using each parameter exactly one time, and the order of the underscores is going to be the order of the parameters. So the first time an underscore appears, that's your accumulator, and the second time an underscore appears, that's the current element that you're considering. I don't really recommend this, especially as you're first getting used to this stuff, but that option is there if you want.
This example, can you explain which parameters play those two?
So the first underscore that appears will be your accumulator variable, where all the results are being accumulated, and the second one is going to be the current element that you're currently considering, which is going to go through the whole list. So this is the same as the previous example, where I'm replacing this with an underscore and this with an underscore, but there's still an accumulator and the current value that I'm looking at. So the same thing, but we can use that shorthand again to be able to crunch this down, get rid of the whole parameter list, and then convert these into underscores. Oh, and I should mention, it's on the slide, but I missed my closing paren there. It's on the slide, but worth mentioning. This example does break if 1 is not the first element, because I never square the first element for what it's worth. 1 never gets squared in this, but luckily the square of 1 is 1, so I kind of sneak that one past. But the first element never gets the function applied to it. Something to keep in mind when you use reduce. Which sounds like a pretty bad limitation. So enter fold. Fold is going to do something very similar to reduce, except instead of taking the first element of the list as the initial accumulator, you'll explicitly set the initial value of the accumulator. So now even if 1 is not my first element and I want to make sure that gets squared, or multiplied in this case, I'm going to specify what my initial accumulator should be. And then when we call this is the accumulator, and then this will be the first element that we consider. So now every element is subject to being processed without having the first one just be your default accumulator value. And I changed it to just multiplying all the values instead of the sum of the squares. But same idea other than that. Fold works just like reduce, except you set an initial value for the accumulator, and we have a function with 2 sets of parentheses, which gets wild. We're calling fold with an element, which returns a function, which takes a function. It gets wild. What we can do when we have first order functions, we can combine these functions, we can compose these functions, all the kind of math stuff that you learn. Compose functions that take functions that take functions. We can do all kinds of cool stuff with that. And have lots of flexibility and complexity in our code. in very little lines also. Multiply all the elements of this list. Pretty short. I'm using that shorthand again. Accumulator and current element that we're considering. Which multiplication's commutative anyway, so, or cumulative, associative anyway. So it doesn't matter, but for the sum of the squares, oh, I guess that is too. I should have done one that's like subtraction, but. And there are different versions of both fold and reduce. Fold left and fold right. So fold left and fold right, and reduce left and reduce right are going to determine which order you go through the list. Reduce or fold left and reduce left are going to go the order that we just talked about. It's going to start at the beginning of the list and go to the right. It's going to start with the left. And the accumulator is going to be the first parameter, and then the value you're looking at is going to be the second parameter of the function. You can go the opposite way as well. Fold right is going to start on the right end and go to the left. And the order of the parameters does change. Your function is going to take the element you're considering and then the accumulator. They do swap the order of the parameters on you when you call right. So if you are using that for whatever reason, honestly, you probably don't need this on your homework. Map is going to be super powerful, but the fold and reduce, you can use them. They will make certain things simpler, but if you don't use them, you'll still get through the homework, to be honest. Especially when you get to the application objective, they can be very useful, though. But fold right is going to start from the other end and start eating things from the right and start accumulating into this variable. So I always think of the accumulator traveling across the list and kind of absorbing the values as it goes. The accumulator starts from the left, or the accumulator starts from the right and absorbs these values. If you just use fold or reduce, you'll get fold left and reduce left. So fold and reduce, they don't do anything except call fold left and reduce left. They just defer to the other method to be able to do that. So the default is using fold left, and then if you want to specify right, you do fold right. So why would you ever call fold left if that's the default? And why would I ever even want to go from the right? I don't know. I've never had an application where I'm like, I need to do this from the right side of the list. But if you want to change the type of the elements, then you have to specify either fold left or fold right. Even though fold just calls fold left, it doesn't have an extra type parameter. Fold left has two type parameters, the type of the list and the type of the output. But fold will call fold left with both of those type parameters as the same type parameter. Why they set up like that, I don't know. I have no freaking clue why they did that. But if you want to change the type, here I have strings, and I want to convert them into ints and sum up the length of all these strings. Or if I want to iterate over lists of doubles as genes, and I want to convert them all to a single animal, why would I want to do that? That's not the best example. But if I want to fold into different types, fold left, give it an accumulator, initial value for the accumulator. Based on the type of that value, that's going to be the type of the outputs. So I gave it an int here. Now the output is going to be an int, and my function has to take in an int and a string, the accumulator and the value I'm considering, and return an int. And now I'm going to sum up all of the lengths of the strings in this data structure. So if I just use fold, it will be fold left, but I won't be able to change the values of those things. Oh, crap. That announcement at the beginning took up more time than I thought. Are we really at the end? I just want to highlight a couple because we got to do the lecture question. I lost track of time there, sorry. Dot sum, if you have a list of number values, numeric values only, dot sum will give you the sum of all of them. If you're computing average, that might be handy. And distinct is going to give you only the unique elements in a data structure. It's going to remove all the duplicates for you. So distinct, also pretty handy. Slice, reverse we've probably seen, but we don't have time for that. Oh. Ooh. That's not the lecture question. All right. That's why I color code them, so I know if I put up the wrong question. But we got the question here. I did talk about all these, right? For each, filter, reduce, fold, maunder. All right, cool. And then when you're done with the question, have a great day, and I'll see you Friday. One more lecture before break.